This is an integrated circuit, or IC. From the outside it looks nothing more than a plastic or ceramic block with metal legs, but inside it's packed with electronic circuitry. It's this circuitry and its powerful capabilities that are used to control most of the world as we know it today. Engineers use very simple drawings to describe complex ICs. These simplified drawings are called schematic diagrams and look like this. The IC is the black block and the metal legs connections are shown in red, numbered and labelled. Breaking open an IC reveals its inner working chip, which is normally tiny compared to the overall package size. Small wires can be seen here that are used to connect the circuitry on the chip to the pins in the outside world. Some ICs perform very simple functions, whilst others can be large and very complex. Producing ICs has become easier over the years and the price has fallen considerably. They are cheap enough for us to use in projects and play with here. Soldering integrated circuits into printed circuit boards makes them even easier to handle and facilitates connections with other devices. The example shown here is called the Ardunio Uno, and it's an extremely popular little board with millions already been sold around the world. The Arduino Uno is the board we're going to use throughout this project, and because we can touch it, it's called hardware. Looking at the board, you can see around the IC the ancillary components that are used to help it operate. Around the edge are connectors called headers. These headers allow us to insert wires that can connect to further electronic components and circuits. The white rectangular block is called a breadboard, and with it we can easily push in wires to interconnect switches and sliders for control, LEDs as indicators, motors for movement, stepper motors for precision movement, heat sensors to record temperature, passive infrared detectors to see evil, electronic compasses and accelerometers to detect movement, GPS modules to know where in the world you are, GPRS modules to send and receive messages via mobile phone, and/or Wi-Fi for internet connection. All of these additional components enhance the power and capabilities of the basic Arduino Uno and gives us superpowers. But how do we get the Uno to understand what we want it to do? How do we command it? This is the function of the second half of our armoury, the bits we cannot touch. It's called software. With the Arduino, we write software on another machine and then upload it. Coupling the Arduino to a second machine provides us with all the control we need. The second machine can be a desktop, laptop, tablet, mobile, Raspberry Pi. All we need is a USB port. Programs called sketches in the Arduino world are written, checked and compiled on the connected device. Once this is completed correctly, the code is transferred or uploaded to the Arduino for implementation. Software configures the Arduino and commands it to set up pins as inputs to receive signals from the outside world and outputs to control objects in the outside world. In the middle, software is also a list of commands that Arduino will run and quickly perform the calculations that turn the inputs to outputs. But what are these inputs and outputs? The Arduino is a digital device, and if you had a special pair of glasses that could examine what was going on inside, you'd simply see the circuitry switching on and off. Everything these days appears to be digital. Digital discs, digital radio, digital TV. But what is digital, and what was used before digital came along? Digital here means numbers, and computers use a limited set of numbers restricted to 0 and 1. These zeros and ones can be on or off, true or false, but computers operate so quickly they deal with much larger numbers, and we will shortly discover how they do this. Before digital, the world was analog. Rather than just on or off, analog can vary. Perhaps the best demonstration is light switches. Normal light switches are just on or off. Dimmers, on the other hand, allow us to vary the light level. Dimmers can make any value from off to full on, and any level in between. The inputs on the Arduino can deal with digital signals from buttons and switches, and analog inputs from sliders or knobs. As you may expect, it can also output signals that are digital and can appear to be analog. All connections to the Arduino are electronic, both input and output. In the final part of this course, we will learn how to control these signals so that they are large enough to, say, light an LED, or small enough so it's safe to use on the Arduino. We will also look at some brilliant online facilities that allow you to design, document, and even produce your own printed circuit boards. On the way, we will cover schematic drawings, breadboarding, and soldering. So, we have a Uno, a very popular and low-cost board that can even be powered from the USB port. High-quality software that is free to download and use, that works with many machines, a wealth of online community support, a wide range of add-on boards, and good links to electronics and the ability to build your own circuits. So let's progress.